Good evening, everybody, and welcome to episode 14 of The Round Table with Sleeping Warrior. And the topic today is going to be gravity cannot hold the atmosphere to the Earth. Tony, are you there?
Yeah.
Yeah. Now, you've been a busy boy today, haven't you? You've been all over the place.
I've been sat in traffic and in accident traffic at rush hour. It's been horrendous. I was supposed to be on with Jose, and I ended up having a change of routine, and it ended up causing me to be out in rush hour when I shouldn't have been. And when I was out in rush hour, I got stuck in rush hour traffic and an accident damage, which made it even worse. It's been horrendous.
Damn. Well, you're here now, that's the main thing. It's a good job I was scheduling this for 10 o'clock, so happy days. Right, are you ready to present?
I am.
Excellent. Right, okay. Pop yourself on screen share, and we'll get this show on the road.
All right, so this is a little bit unusual. Are you seeing my PowerPoint presentation right now?
I am, and just give me 1 second, and you will be on. There you go. You are now screen sharing, and the time is yours.
Okay, so somebody's just stuffed a marshmallow in my mouth. Right, so usually you would normally have a presentation, and then people would then ring in and criticize or ask questions based on it before it really goes public. But this is like back to front, because I've already demonstrated this on Jose's channel about 2 hours ago, where I had George Netanyahu, who claims to believe in gravity and claims that we live on a sphere and claims that gravity holds the atmosphere on. And I'm here to demonstrate today that this is nonsense. And it's already been challenged. So basically what this is demonstrating is that there's no baller that has any science to explain why the Earth's atmosphere does not immediately burst into the vacuum of space. We do live in a pressurized environment of some kind. I know at the minute Spurs is questioning it, and I'm cool with that. I'm quite with that. I understand his position, and I'm not against it. I'm not for it necessarily at this point. I'm kind of querying it with him. I'm trying to understand his argument really. But if we've got a gas pressure at 14.7 psi existing next to a vacuum of space at 10 to the minus 7 torr, without a membrane, that pressure immediately fills the vacuum of space. Immediately. Now, these ballers tell us that gravity is a thing. But I've recently realized that gravity is not a thing, and Einstein tells us it's not a thing. But everybody thinks that gravity is a force. So what I'm going to present to you today is that gravity is neither a force, nor is it even the current science. And I'm going to tell flat earthers that we need to be pushing the ballers to demonstrate the claims for gravity. And I'm going to tell the ball earthers that none of you have got evidence to explain the atmosphere. And even if we consider gravity to be a force as per Fight the Flat Earth and George Musa, it doesn't explain the scenario that you have. We do have gas pressure. We breathe it. But we exist next to a sky vacuum, as Nathan would say. That sky vacuum can't exist next to a pressure. But you morons think it does. So there's clearly a contradiction. And I'm asking what's really going on. And asking questions is the way that we should all be. So the reason for the claim is that if you look at the Action Lab, you'll find that you can search for helium balloon in a vacuum, and you can find this video. This is my citation. This is my reason for why I'm questioning it. And all they do is they get little water balloons, fill them with helium because they're a good size to get in their little vacuum chamber. And when they fill them with helium and then evacuate the chamber of its air, you'll notice that the balloons, initially, they float, but when you start removing the air, they appear to, grow. So when he first puts them in the small, then they're beginning to get bigger as he's removing the air. And then they get even bigger, but one of them appears to drop. And then eventually, the other one drops. Now, this can comprehensively and fully be explained by relative density. But we're told that this is gravity. I don't think it is gravity. There's no evidence that this is gravity. This is literally the medium that these balloons are in is reducing in its number from, we'll give it an arbitrary value between 1 and 10. Let's say the medium was 1. And the helium balloons are kind of 1.2. They're a little bit heavier now. But before the medium was changed, they were 0.8, and that's why they were floating, because they were less than the medium that they're in. But now you remove that medium, and it changes, relatively speaking, and that's why relative density is what we're looking at. But they tell us it's gravity. Well, that's what I'm asking. How do you know it's gravity when we can manipulate this with relative density and get the same results without needing gravity whatsoever? Why would you infer that there's something there that I say that you can't prove, and even Einstein says isn't even a force? But we'll come to that. So what happens at this point is one of the balloons bursts, and when it bursts, it raises the question, well, what happens to the gas pressure that was in the balloon? Does it pool at the bottom because it's more dense than the medium it's in? Or does it fill the available volume? We're told it fills the available volume. It could equally pool at the bottom. Who knows? We can't see it. We don't really know what's going on. But it's either it fills the available volume or it pools at the bottom because it's more dense than the medium it's in. I don't know which is which, and that's part of the question. But I've put at the bottom, I've put, at this point, the balloon bursts and the gas pressure instantly does something. What it does is not important. The focus is on the word instantly. Whatever the bursting balloon does, it is done instantly, but not gradually. There's no density gradient. There's no pressure gradient. Whatever happens, it does it bang. It's like a gunshot, instantly. This means that if our Earth was exposed to the vacuum of space, Earth would be the balloon. Instantaneous and violent explosion into the vacuum is what happens with that pressure. So if this is the Earth's atmosphere, without a membrane, it's going to fill the available volume. It's going to immediately burst into space. Everybody can understand that. Everybody can relate to that. The problem is when you walk outside, there's gas pressure. So how is that possible? Fundamentally, that's the question. Isaac Newton's laws of motion are claimed to be laws. They apply always. Newton's got 3 laws of motion, and one of them, everybody knows that an object at rest will remain at rest unless acted upon by a force. But not everybody remembers the second part to it, which is that an object in a state of motion will remain in that state of motion unless acted upon by an external force. If the atmosphere is under pressure and it's pressing up against something, which in our case is the vacuum of space at 10 to the minus 17 torr, then there needs to be a force to stop it from bursting into the atmosphere, bursting into the vacuum of space. Because it requires a force according to Newton's laws. Now, these aren't my laws. This is not my interpretation. This is Newton's laws of motion, and I'm citing this from Stanford, but you can check this. If you don't believe me, you can check it. You can go to Google, type in Newton's laws of motion, and you'll find them. An object at rest will remain at rest unless acted upon by a force. An object in motion will remain in motion unless acted upon by a force. That's his rules. They're his laws, no, not mine. I'm not misinterpreting that. That is what they are. Check it. You'll see that I'm right. If you then type in gas pressure, you'll find that you get a generic pressure definition, which is the force exerted by the substance per unit area on another substance. And then you get the pressure of a gas is the force that the gas exerts on the walls of its container. So we know that you need a container to have gas pressure. That's why Nathan's got housekeeping. We know that you have to have containment to have gas pressure. NASA, and you can find this just by doing a rudimentary search on Google, tell you that air pressure is pressure force acts perpendicular to enclosing surfaces. Well, we do have gas pressure, and we know that it's pushing down on us because apparently we can feel it. Shout outs to Matt Doxey. But we can feel the gas pressure, apparently, but it's pressing on all sides, not just on the Earth. It's pressing in all directions. But as Nathan correctly points out, what's it pressing on at the top? Because there isn't any resistance. There is a vacuum, which is, I'm going to say the word sucking. Yeah, I know you're all going to shout at me for saying sucking. Vacuums don't suck. But that pressure is trying to explode into the vacuum of a space. And we know when the helium balloon bursts, we know that it does it instantaneously. It's like immediate. I'm going to call it an explosion. So we know that this is what happens. And NASA tell us that the pressure inside the balloon acts perpendicular to all enclosing surfaces. So imagine that this balloon is the Earth. We know that, according to NASA, that the gas pressure exerts itself perpendicular to all enclosing surfaces. When there's a balloon there, this makes perfect sense. But when there's not a balloon there, we haven't got anything stopping the pressure of atmosphere pressing against something because there isn't a balloon encapsulating the Earth on their model. I'm not being pedantic when I ask what's stopping the atmosphere from bursting into space. Because at least if we've got a balloon, there's a membrane of some kind. Whether it's adequate or not isn't the point, but there's at least something to stop it. There's something that's bouncing the gas pressure back down to Earth. But if there's no balloon protecting the Earth or the atmosphere of Earth, we have a problem. It's a legitimate question. From a flat Earth perspective, it's bloody obvious, but from a ball Earth perspective, well, they need a force. NASA tell us that the force must be exerted on the insides of all its surfaces. We have gas pressure pushing out in all directions, but we haven't got a membrane. If Newton's laws are true, an object in motion will remain in motion unless acted upon by a force. That's one of his laws. They do need a force. Albert Einstein, according to Wikipedia, the reliable source that it is, that can be manipulated and altered and edited by anybody, which, by the way, check the recent editions or the recent editings from his theory of relativity, general relativity. You'll see that flat Earth references they've removed the superseded bit. I digress. According to Wikipedia, gravity is most accurately described by the general theory of relativity proposed by Albert Einstein in 1915, which describes gravity not as a force, which is a problem because they need something to stop the atmosphere bursting into space instantaneously, but as a consequence of the curvature of space-time caused by the uneven distribution of mass. That does not explain what's stopping the atmosphere from bursting into space. Fact. Whatever bendy space-time may or may not do, it seems to be addressing the orbits of the planets around the sun. It adds nothing to the explanation for why the atmosphere does not burst into space. This is a legitimate question that flat earthers are asking, and all flat earthers need to keep asking it, because we want the science that demonstrates what's stopping the atmosphere from filling the available volume immediately of the atmosphere. Ball earthers need to come up with the science that demonstrates this to be true. Whatever atmosphere may exist, demonstrate that it can repel or it can counter the pressure disequilibrium of 10 to the minus 17 torr against 5, 10, 2, 6, 1 psi. Show that something can do that without a membrane. Of course you can't. What did they come back and say? Pressure gradient. Doesn't do it instantly. Well, you can't have a pressure gradient because it's done instantaneously. The balloon burst instantaneously. The balloon did not burst with a pressure gradient. The balloon burst instantaneously. The word is instantaneously. We want to see citation that demonstrates that gas pressure can exist next to a vacuum without instantaneously filling the volume. And that's what we know that happens. It can be demonstrated. We know we can demonstrate it because the balloon burst instantaneously. It didn't slow burst. It didn't gradually density gradient burst. It burst instantly. This debunks the idea that you can have gas pressure next to a vacuum without containment. Literally debunks it. If you don't believe me that gravity is considered to be the leading science, just go to Google and type in, "Is gravity a force?" You'll get a variety of answers, and you can read them all yourself. I'm not going to present them all. You can do it yourself to try and debunk me, and then you'll realize that gravity is not a force. This top citation from Cornell said that Einstein said there is no such thing as a gravitational force. Mass is not attracting mass over a distance. Instead, it's curving space-time. In the context of the atmosphere, that adds nothing to the atmosphere argument. This is the one that Quantum Eraser gets misrepresented by Blue Marble Science on. might not be him actually, don't quote me on that. I stand corrected. I can't remember who it is. Somebody says that Quantum Eraser has misrepresented this citation, how we know gravity is not just a force. Well, if you actually look at what Quantum Eraser actually said, and then reference the bit that he actually said, he hasn't misrepresented it. The ballers are just lying about him because they need to discredit him at all costs, because he's got an absolute killer argument against the ball having an atmosphere next to the vacuum of space. We've all heard the rumpus claim that you can stand on a set of scales, and this is literally addressing rumpus. When we think of gravity, we typically think of it as a force between masses. When you step on a scale, for example, we've all heard rumpus say that. This is referencing the rumpus. Try it yourself. Is gravity a force on Google? If you find anything that cites gravity to be a force, let me know. I'll stand corrected. There isn't any gravity being a force citations, because gravity is not a force. Albert Einstein's the current science, and he said it's not a force. If you want to think of it as a force, as per George Musa and Fight the Flat Earth, you can be a moron and think of it as a force. Don't make it a force though, does it? If it's not a force, it's not a force. I had the hangout with Jose. George Netanyahu was my opponent today. This is the conversation that I would imagine that Einstein would say with George Netanyahu when George Netanyahu claims that gravity is a force. Einstein says to George, I am the current science for gravity, George. I say it is not a force. It is the effect of the curvature of space-time. You will find that everywhere. George, you will obey my science. You will not deny my authority. George would then respond and say, but I need it to be a force, or the atmosphere will do what the helium balloon did, Albert. An apparent force? But an apparent force is an effect. I need a force, Albert. Please help me. Newton said I need a force. It's in his laws of motion, Albert. An object at rest will remain at rest unless acted upon by a force. But an object in motion will remain in motion unless acted upon by a force too. If the atmosphere and the gas pressure of the atmosphere are bursting into the vacuum of space, they do need a force. George would be pleading with Albert to say, I need a force. Albert doesn't give him a force because gravity is not a force. This is how it would go. Albert would say this to George. Next slide. Albert. Tell him that the gradient was slowly dispersed into space then. And of course, that is what they say. But Riley is specifically addressing the words instantaneously, Albert. The balloon burst instantaneously. It did not slow burst how our atmosphere does. Anybody that tells you that gas pressure can exist with a gradient next to a vacuum is denying the fact that it's an instantaneous transfer of energy. The balloon does not burst slowly. The balloon bursts immediately, and this debunks their claim. And all the science supports it. They can't demonstrate a balloon bursting slowly. Riley is right. The Earth's atmosphere will instantaneously burst into the vacuum, George. My gravity cannot help you here. My gravity only results from the curvature of space-time. Even if space-time could cause anything, it cannot help you explain this issue away, I'm afraid. George. But you're the king of gravity, Albert. You debunked Newton in 1915 with the current science for gravity, right? I need your help here. I can't let Riley kick my arse. That means we don't live in a vacuum of space. And if we do, we must be in some kind of containment after all. Albert says, remember my words in the publication of January the 2nd, 1920, George. Quote, these are Albert Einstein's actual words. The great attraction of the theory is its logical consistency. If any deduction from it should prove untenable, it must be given up. A modification of it seems impossible without the destruction of the whole. Well, if gas pressure can exist next to a vacuum, I'm going to argue that that actually is a deduction from it. And it does prove untenable. And it should be given up as the whole. However, it is the current science for gravity. I don't agree with Albert Einstein. It's a mathematical construct that's got no experimentation applicability whatsoever. You can't do it with experiment. You can't test it. Bendy space-time. What does it even mean? We know what it means. We know what they tell us it means. It's the fabric of space-time. We can't test it. It's a theoretical construct that exists only in mathematics. But Albert Einstein's own words say, if any deduction from it should prove untenable, it must be given up. This is their current science. Then he says, no one must think that Newton's great creation can be overthrown in any real sense by this or by any other theory. His clear and wide ideas will forever retain their significance as the foundation on which our modern conceptions of physics have been built. He's passing the buck back to Newton. But we know that Newton said, do not ascribe gravitation to me. It seems to me that so long as we're talking about gravity, it doesn't matter whether you agree with Albert Einstein or Newton. So long as we're talking about gravity, it reaffirms the position that gravity is a thing. But Newton said you need a force to stop the atmosphere bursting into space, whereas Albert Einstein said gravity is not a force. So if one says you need a force to stop the atmosphere bursting into space, but the other one says it's not a force, what are we left with other than obfuscation? It's a rhetorical question, but think about it. If you're on the flat earth side, both arguments are contradictory. If you're on the ball side, you haven't got any science. So which is it? What explains the atmosphere from bursting into space? The answer, of course, is none. We're not living in what we're told. Einstein would then finish by saying Riley's got a point. There does seem to be an untenable deduction from my work. But even so, it is still the current science for gravity, George. George will have to debunk Einstein to claim gravity to be a force. Because Einstein is the current force. Like it or not, that's considered to be the current force. Let's stop talking about Cavendish. Let's stop talking about forces. Isaac Newton was replaced by Einstein in 1915. I don't even agree with it, but that's their current science. Let's ram it down their throat. Even if it isn't, everybody thinks gravity is a force anyway. Even though I am the current science, George. And obviously he says it's not a force. If you think I'm wrong, George, that's okay. But I can't help you with an explanation for why and how the atmosphere doesn't instantly burst into the vacuum of space. My gravity is not a force. Riley is right. That's what Albert Einstein would say to George. You can't claim that gravity is a force if it's not a force. Even if you want to think of it as a force, it's still not a force. My car in my garage is not a Ferrari. Even if I think of it as a Ferrari, it's not a Ferrari. That's what they're trying to say. Final 2 slides. There is no science to even explain, let alone demonstrate, how an apparent force can cause anything. If F equals ma, but Einstein said that gravity is not a force, there must be something pulling down on the atmosphere. But it can't be gravity because Albert Einstein expressly states that it's the effect of the curvature of space-time. The effect, not the cause, the effect. Ballers can't do causation in this instance. They claim causation, they obfuscate the point to death, but it doesn't change the fact that Albert Einstein's the currently accepted position for gravity, and it's the effect of the curvature of space-time, it's not the cause. This is not even contentious citation, this is the current science. A pressure gradient is inconsistent with the bursting balloon, but is just like the cherry tomato sat in its own pressure gradient caused by the liquids around it, otherwise known as relative density. What I'll do here is I'll bring up the cherry tomato for those that may not be familiar. Bear with me. It seems to me that we, the humans that live on the planet, are the cherry tomato. It seems to me that the atmosphere, the layers of the atmosphere, so we've got the nitrogen at the bottom, the oxygen above it, right at the top we've got the hydrogen and the helium, and then we've got a couple in the middle. That seems to be our atmosphere layered in a density tower. Everything below it is Earth. That seems to me what we're actually living in. George failed to answer the one and only question that I asked of him. We know that gravity is not a force, but we also know that you need something to explain why the Earth's atmosphere does not instantly burst into the vacuum of space. The word that you need to focus on both sides of the argument is instantly. The balloon in the helium balloon in the vacuum chamber immediately bursts instantly. It's like a gunshot. What force is slowing down that instantaneous bursting into the vacuum that our atmos must do if gravity is not a force? But we do have gas pressure. We're breathing it right now. Apparent forces cannot cause anything, or they would be called forces. So what force is stopping the atmosphere from instantly bursting into space, please? And if you're going to make a claim, present some evidence to support it. But there is no science that demonstrates how you can have a gas pressure existing next to a vacuum without instantly bursting into it and equalizing or equilibralizing. You can't have gas pressure without a container. You can't have gas pressure without containment. We are in gas pressure, we're breathing it. Spurs is questioning whether or not we're actually breathing gas pressure. And to be honest, there is an element of curiosity in there from my position, because we either don't have gas pressure, the way Spurs is questioning, or we do have gas pressure, but it's contained. But either way is not the model we're told. So there's definitely something that needs to be demonstrated by ball earthers if they're going to claim science. And let's not forget the definition of pseudoscience. If you can't demonstrate it within scientific method, it's pseudoscience. What is the explanation with the supporting science and evidence to prove that we have gas pressure next to a vacuum? George Netanyahu failed miserably today. George left at the point where I was literally at the crescendo of my point. Okay, he did have a prior arrangement, that much may be true. He did tell us before he left. The rumpus came in and carried on for him. The rumpus can't answer the question. Claims he can, claims that I don't understand it. But if there's anybody out there that thinks I've got something wrong, please present the supporting science that proves that I am actually wrong. You can't have gas pressure without a container, but we do have gas pressure, we're breathing it. You can't have a density gradient because it would instantaneously fill the vacuum of space. The atmosphere cannot exist if we are next to the vacuum of space. There needs to be containment. There needs to be a membrane of some kind, because we're breathing gas pressure. Gravity is not a force. Einstein said so. What's going on? I am more confused now than I ever have been. None of it's making any sense. There's no science to demonstrate it. If you're on the flat earth side, you've got to ask the question, what's going on? If you're on the ball earth side, you've got to demonstrate and prove what is going on. We are breathing gas pressure. Or maybe Spurs is right. Maybe there is no gas pressure. Maybe, just maybe, we're breathing gas in a density column caused by the weight of the gases above us within a contained environment. Spurs may be right. But if I was to hedge my bets anywhere, Spurs is probably more right than the atmospheric pressure not bursting off into space because of gravity, because we know it's not a force. There's more credibility in Spurs' argument than there is in any of the ballers' arguments for gravity being a force. If there's any baller out there that can demonstrate that I'm wrong, join the panel with Ranty right now. Present your supporting evidence, not your opinion. Present your supporting evidence that I've got something wrong. Let's demonstrate that I've made a mistake. I want to see proof that the atmosphere can exist in a vacuum without instantaneously equilibralizing. Anybody join the panel? Make sure you've got evidence. I'm done.
Well, thank you very much, Tony. Do you want to pop your watch page on mute? Perfect, right. Listen, normally at this point I would play a video. However, the chat's running riot. Are you prepared to take questions right now, Tony?
Yeah, bring it. But make sure if you're going to ask questions, if you're going to challenge me, I want to see some supporting evidence. Don't make baseless assertions. Present something that shows that I'm wrong. Because if you can't, then I'm only asking the question, how can you prove that we've got gas pressure next to a vacuum? So bring it. I'm all for it. I'm ready. Let's go.
Okay, so first question that I noticed recently from Daniel says, question for Riley, do you accept that every physicist on Earth agrees that Einstein's general relativity explains orbits, or why the atmosphere doesn't disappear?
I accept that all the scientists or physicists accept Einstein for orbits. I'm not satisfied that any of them accept Einstein for the atmosphere.
Okay, so we want a yes or a no. So there's a couple of questions from Bob the Science Guy. He just wants yes or no, no fudging, no hedging. Obviously, you don't have to answer if you don't want to, so it's up to you. Question: is Riley saying that gravity does not act on the atmosphere? Yes or no?
Einstein says that gravity is not a force, so it can't act on the atmosphere. But let's not forget that Bob the Science Guy doesn't accept that you must manipulate the independent variable in a scientific experiment. He thinks that you can correlate. So I'm not sure that he's a credible person even in this topic. But the answer to his question is no. Albert Einstein is the current science, and it cannot act on anything because gravity is not a force.
Okay, so the next yes or no question. Is Riley stating as a fact that there is an enclosed container holding in the atmosphere?
You cannot have gas pressure without some form of containment. Whatever that containment is, maybe it's a dome, maybe it's a droplet under an ocean, but there is gas pressure. It's like John says, you can't have steak without a cow. If there are no cows, you get no steak. If dodo birds existed, we might be able to eat part of a dodo bird. But we don't have dodo birds, so we can't eat part of it because the dodo bird doesn't exist. But we do have gas pressure. So there has to be some element of containment, be it a dome or otherwise. Something is keeping the atmosphere from bursting into space instantaneously.
So is that a yes or a no?
So what was the question? Is Riley saying what?
Is Riley stating as a fact there is an enclosed container holding in the atmosphere?
There's got to be containment. The answer is yes.
Okie dokie. Right, next set of questions are from Ruhif. So, does mass in a vacuum accelerate towards the ground?
Does mass
in a vacuum
accelerate towards the ground? Depends on where the ground is.
Yeah, there was a statement before from somebody. I'd have to look back to try and find it, but they stated that there's no way that you can make a perfect vacuum here on Earth. Would you agree with that?
Yeah, absolutely. 10 to the minus 17 is the best vacuum that science accepts exists, and we can't recreate it. You need to do a chemical leaching process to even get close to it, and even then, I don't think you can achieve it, according to what we're told. So, yeah, I don't agree that we can recreate a perfect vacuum on Earth. Even if we could, I don't think it makes much difference because the key part to it is the differential between the atmospheric pressure of 14.7 psi against the 10 to the minus 17 torr. It's the differential that's important, not specifically the strength of the vacuum. It's the differential. You can't have a differential next to each other.
So the question, does mass in a vacuum accelerate towards the ground? Would you contend then that there's no perfect vacuum, so it would have to go to the ground, or is there a different response to that, or
the answer is which direction is the ground? If you're referring to down is a relative direction. I know Bob from Globebusters says it's an absolute direction, but it's not. The only absolute direction that we can reliably rely upon is the direction that the compass points. We're told about declination and whatsoever, but if you just type in relative directions, down appears as a relative direction. And the reason why it's a relative direction, it needs a human to interpret that direction. Without the human, there is no direction. So down is a relative direction. If you're going to say that ground is down, maybe, but it's still relative. So it depends on how you define ground.
Okie dokie. Does the atmosphere have mass, Tony?
Gases have gases have atomic masses, yes.
And finally, this is from Ruhif, which I found quite funny. He says, can you watch the first 5 seconds of a Nyatanyik video to hear him pronounce his name?
Of a what video?
George's surname. I don't know how to say his surname. I presume we're saying it wrong. And I think,
who cares? Who cares? Everyone knows who I'm on about. It might not be pronounced right. It doesn't change the point I'm making. So if it's not Natanyuk, who cares?
Okay, so please ask Anthony what he means by next to. Does he really mean 50 miles apart?
Yes.
Okay. Right. So I'm catching up, guys. So if you're spamming questions, I'm quite a way behind here. So let's catch up. 'Cause I'm catching up slowly here. From Sean Hawkins, ask him why he left out the part where he showed up to 1.5 hours late.
Sorry, something happened in the background. Ask him why he left out which part.
Yeah, it doesn't really matter. It's not really important.
Sean Hawkins doesn't understand the burden of proof. Don't bother with his questions.
Hang on. Let me refresh it. Wow, I've got so many questions to go through. Right, hang on. Right, okay, so Anthony got debunked on this just 30 minutes ago by his own evidence. Ask him why he's lying right now. The citation from Einstein says that Einstein's theory does not replace Newton.
I need the citation that he's referencing that he claims debunks me, but listen, there's nobody that can debunk this argument. If you think you can debunk the argument, join the panel. Ranty, send him the link. Let's see you present what you claim is a debunk, and I'll rip it apart right in front of your face. Join the panel, dickhead.
Question from CrowXE, who's done a presentation on this before, well, on this channel before. So, defined next in terms of distance, which I think you've just done. And do you know that the atmospheric pressure at 35 kilometers is 0.005 atm, and he has citations.
So what? Compare it to 10 to the minus 17 torr. That's the comparison.
Okay. Question: why the 1 atm pressure at sea level don't go up to 0.001 atm at 38 kilometers?
Right, 0.001 atm. If you did the math on that based on 14.7 psi, it's nowhere near 10 to the minus 17 torr. Again, scale's the issue here. The differential between the two values is the issue. We should be referencing 10 to the minus 17 torr, the most perfect vacuum that science can't even create. That's what we're told space is, and we're told we've got a gas pressure next to it, touching it, in it, and we know we can't have that without a membrane. So let's get the scale right. 10 to the minus 17 torr is the reference that you should be using.
Okay, so Bob's finished his line of questioning. He says, thank you, Ranty. That's all he had for yourself. But we have a question from Chris Cruel, who says, isn't gas pressure energetic molecules ramming into each other? Why does there need to be a container for molecules to ram into each other molecules?
It's in the definition. Just type in gas pressure definition and you'll see it.
Could you elaborate a little bit on that?
It's in the definition. Just type in gas pressure definition and you'll see it. It requires a container.
Okay, so Ruhif wants to rephrase his question, and he says instead of in a vacuum, in a vacuum chamber. So I'm assuming that's about the does objects fall towards the ground or the earth in a vacuum chamber?
It does, but when you say the ground, if the vacuum chamber has got a medium density value of 0, and then there's a mass that has a value greater than 0, it will displace the medium it's in. If that happens to be to the ground, then the answer would be yes. The question is the ground the correct reference point? And the answer to that question is, I don't know.
Okay, so we have a question.
I could counter it with, what would happen if you dropped an object in an infinite vacuum, or an infinite length vacuum? Would it continuously increase its velocity until it got to the speed of light? It's a rhetorical question. I don't expect him to answer because I know we can't answer it. But what happens if you carry on doing it in a vacuum? Does it continuously accelerate? Who knows?
Okay, so a question from DWheel39. Have any ballers been able to demonstrate gravity being able to hold back objects from flying off on a spinning object, countering centrifugal force?
The answer is no, but it depends on what science you accept, because Einstein said that gravity is not a force. Newton said you need a force, but Einstein said there isn't one. So I don't know what they would explain that to be. So they have never demonstrated any part of this argument. So the answer is a clear, straightforward no. But they do need to do something, because there's a clear contradiction here. Newton says you need a force. Einstein says he hasn't got a force, but you all believe it anyway. Well, we're just saying, well, what is the science here? Because if it's not a force, but you need a force, what is holding the atmosphere on the Earth from instantly bursting into the vacuum of space? You can't have a force of gravity if it's not a force, and that is your current science. It's not okay to deny Einstein, which we are told is the current science. I don't know what is the answer, but you guys don't seem to know it either. But you guys are supposed to know all the answers.
Right, okay, so if you can't have a differential next to each other, then why doesn't 14 psi at sea level instantly blast off into the elevation around the top of Mount Everest?
Because we have to be contained. If we weren't contained, it would do it instantaneously. This is the point that ballers are missing. You can't have a gradient next to a vacuum of space unless we're in a contained environment. It's the antithesis of the argument that they present. We have gas pressure. We do see a gradient. We do see the cherry tomato in a container, and there is a gradient above it and below it. We can demonstrate a gradient in a container, but you can't demonstrate a gradient in a vacuum. That's the science that you need to present. So by asking that question, you literally show the failings of your own model. Well done, mate. That was a really good question for demonstrating that we can't be living in an open system next to a vacuum of space.
Okay, so Bob the Science Guy's back with another question. Is the measurable downward acceleration of 9.81 meters a second responsible for the known pressure gradient in the Earth's atmosphere?
No, because the downward acceleration would be a force, and Einstein says gravity is not a force. So if you think that gravity is responsible for the 9.81 meters per second squared, I might add, no, Einstein is your current science, and he says it's not a force. If Bob the Science Guy, the one that denies the varying of the manipulation of the independent variable, if he wants to think of it as a force, Bob the Science Guy can think of it as a force, but that doesn't make it a force. Einstein said so.
Would you be willing to have a quick one-on-one with Sean Hawkins right now, or would you rather leave it for another time?
I'd rather ask more questions. Sean Hawkins doesn't add anything to the conversation.
So from Phil Blacker, Riley, if you jump off a shed, will you float or fall?
Depends on what medium you're in. If you jumped off a shed in water, you'd probably float.
Question, can you prove that the pressure doesn't continue dropping after a certain altitude to stop from dropping to the vacuum of space?
It's not my assertion, that's the Ball Earth assertion that it drops continuously into the vacuum of 10 to the minus 17 torr. I can't prove that, but it's not my assertion. Science has got to demonstrate that that's what it does, and if you look at anything to do with atmospheric pressure, numbers, in the past when I've looked at this, they get to a certain point and then they just put a dash, because there's no data for it, but they expect us to believe it just disperses into 10 to the minus 17 torr. Even though it's a positive value, it's an incredibly small value, but there's a huge differential there between the 14.7 psi. So I can't prove it, but it's not my assertion to prove.
Right, okay, so somewhat of a question from Rock Farmer. Question part one. Well, actually, I'll better wait for him to put his part two in, because he's got an...
No, just ask part one.
Do I understand correctly that will the acceleration depend on the relative density between the object and the medium it is falling through?
The acceleration by definition is a force. The medium that the object is in, if they're in disequilibrium, there is an acceleration caused by pressure. I demonstrated that to be true because I added salt to a solution of water, or just water, tap water. That changed the density of the medium. That change in density resulted in a change in pressure, and that displaced the egg. So the answer to your question essentially is yes.
So part two is, will there be a difference in acceleration on an object of we have two identical tubes with different pressures in them? Yeah, I think it's a malformed question, but essentially that. Will there be a difference in acceleration on an object in identical tubes with different pressures in them?
Yeah, there'll be a difference in acceleration, yeah, because it's to do with the amount of disequilibrium. The further, when an object is placed on a set of weights, what you're actually measuring is not the force of gravity on that object. You're measuring how far out of its disequilibrium it is. And what I mean by that is, if you get an adult and he weighs 15 stone and you stand him on a set of scales, he should weigh 15 stone when you put him in water as well. But we know that the medium change, the density variation, is changing this relative weight. That's why relative density is a thing. But what you're actually measuring is not gravity. And we know it's not gravity, because if it was gravity and it was a force, even though Albert Einstein says it's not, the gravity that you're claiming that we're measuring is a 50 millionth of the object's weight, as per Henry Cavendish. There's no getting past that. So if you're 15 stone, gravity, according to Cavendish, is a 50 millionth of that 15 stone. That's it. So everything else is down to the mass relative to the medium it's in. And we can demonstrate that by putting it in water and showing that it doesn't measure the same value, because water is way more dense than air. So I've lost track of where I was at now with regards to the question.
Okay.
But
well, do you want to ask should we do a different question?
Yeah, go on.
Has yourself ever looked into the barometric equation and how it is derived?
No.
Okay. So, question: since Tony is an expert on the IV, is time and IV, how does Tony manipulate time to follow that definition?
There's only one person that can manipulate time. Well, two, if you include God. Doc Brown from Back to the Future. Unless you've got a flux capacitor in a DeLorean, you can't manipulate time. You can vary the length of an experiment, but you're not manipulating time. Time is a mathematical construct. It's a man-made construct. It's a construct that we use to measure how long it takes for something to happen. But time isn't something you can manipulate. But even if it was, time's never going to cause anything, because cause is something that you've got to manipulate yourself to prove a cause and effect relationship. Time's just something that exists that we call time. It can't cause anything. It's a measuring device. Let's not forget, when Bob from Globebusters measured a 15 degrees rotation of something, he failed to manipulate that something that he measured. And that's the reason why Bob didn't prove that the Earth turned, because the 15 degrees of rotation that he measured is just the same as measuring time. Measurements aren't causation.
Okay, so this is a type of question that I don't really like asking. I'll ask it, Tony, but to be honest, I'd prefer it if you didn't actually answer it. And to me, it seems like it's a set up to fail question, because it's one of these questions that you can research yourself. And it's very simple. What is the pressure differential between 1 psi and 10 to the minus 17 torr? He then goes on to say, I will accept a slightly wrong number. Now, all that's doing to me is that's trying to find you answering the question and getting it wrong. Do you know what I mean? Right. And to be honest, it's one of these things that you can research, you can look it up, and you can find it out yourself. So I've asked
that's all right. I'm all right with it.
Okay.
So 1 psi and the differential to 10 to the minus 17 psi, 10 to the minus 17 torr, is about 1 psi, and that sounds really small. But the differential, if you look at the pressure that was required, or the vacuum that was required to collapse that tanker, and then compare it to 10 to the minus 17 torr, you will see that the differential is absolutely huge. So even though it's only 1 psi, or nearly 1 psi, that doesn't change the fact that you don't need a lot of pressure differential to demonstrate that it can do stuff. And of course, that's what I demonstrated in the conical flask when we set fire to the magnesium and it burnt the oxygen. It only burnt 30% of the air that was inside that conical flask. Shout out to Sean Hufford that thought I'd stolen the video and I hadn't. But that 30% of the atmosphere that it burnt inside that conical flask was enough to make the syringe contract. That 30% of the small amount of volume in there is enough to make a movement. So when you say it's only 1 psi, who cares? That 1 psi differential is huge, and we can demonstrate 1 psi to be huge. So, and it can collapse a tanker. So 1 psi, doesn't sound a lot, but demonstrate it real world, and you'll realize that atmospheric pressure is a force and it can do stuff. If it's doing things, it's a force.
Okay, so from the plain truth, why is
actually do me a favor, ask whoever it was that asked that question to address whether or not I got that question, the answer correct or not, because that is the correct answer.
Daniel, if he got it correct, would you say yes or no? Thank you very much. I've got the feedback coming through from the watch page there, Tony. From the plain truth, why is the meters squared in the rate of acceleration?
Why is the meters squared in the rate of acceleration? That's what they tell us, apparently. I don't know whether... We're told that it's that rate squared. I don't know if it is or not. I've heard criticism saying that that's a parabola, not a rate of acceleration. I don't know. That's just what we are told is the current science. I'm not saying the current science is correct, but that's the reason for it.
Okay, slightly off topic, but then again not, because you did actually put the challenge out inside the actual presentation. But from Sean Hawkins, asking why he challenges Sean, obviously, to a public debate and then chickens out.
Because Sean thinks the burden of proof is on flat earthers to prove that the Earth's flat. He's an utter moron. Sean, you're arguing with somebody that's got a postgraduate diploma in legal practice, an undergraduate degree in law. I understand the burden of proof. Don't dare try and challenge me on what the burden of proof is, you fucking idiot. I'm not even talking to you. You're a prick.
Okay, so looking for some more questions. Right, come on guys, you can get some more questions in here. I'm not actually seeing anything pointed out too much. So from Daniel, the pressure differential there was correctly pointed out by Riley to be 1 psi. I knew he knew the answer, so I didn't want to be mean, but I wanted to build on that fact.
Sorry, ask that question again.
That was from Daniel about the answer to your question. You asked him to answer whether he got it right or not, and he says you did get it right.
Of course I got it right.
Okay, so from right the hand. So down isn't always towards the ground, deeper into the earth, and up isn't always up into the sky going higher. Down and up aren't objective directions, question mark, question mark.
No, they're not objective. They're subjective directions. They're relative to the human. That's why they're called relative directions. Right, the hand is correct.
Right, okay. So from Rock Farmer, who says he botched his question before, so he wants to re-ask his question. So, could you please ask again, if I have two identical tubes, one at 5 psi and one at 20 psi, will objects fall at different acceleration? Why or why not?
Will objects fall at a different rate of acceleration? Right, so pressure will be it depends, I suppose it would depend. I don't know, you'd have to do an experiment on it and practice some science.
Yeah, the thing is, Tony, so calm down. If you don't know, and it's one of these questions that you never even thought about, don't try and guess it. Just say you don't know. That's it.
I don't know. I'd rather someone demonstrate real science by doing exactly that and then seeing what the answer is. I don't know the answer to that.
That's fair enough. I would rather, like I say, I've said this to everyone that's come on, if you don't know the answer, just don't guess it. You know, the worst thing you can do is try and make a stab at something, get it wrong.
Actually, I've got an answer.
Go on then.
I've been thinking about it. If the pressure is 20 psi against the pressure of 5, it would then depend on what the density of the object that's in that pressure would do, because it would depend on how far away from equilibrium that object is. So if you got an object that's like really far away from equilibrium, then that would have a high rate of acceleration. Whereas an object that's really close to its equilibrium point will have a really slow rate of acceleration. So it will be relative to the pressure that's created by the medium that it's in relative to the object in question. So its relative density would be the answer, and it would depend on what the object is.
Okay, so there's a somewhat of another question from CGI Ranty, who asks, why doesn't gravity prevent the gases in a vacuum chamber from being sucked out?
There are no gases in a vacuum chamber. I'm assuming he means before the vacuum chamber is operated to make a vacuum, or does he mean when it is a vacuum? Because if he means when it is a vacuum, then there are no gases.
I have no idea. I looked at it and I thought it's a malformed question, but there we go. So from Daniel, okay, so why can we have a 13 psi pressure differential between sea level and 80,000 feet without a barrier, but a 1 psi differential between 1 psi and 10 to the minus 17 torr is impossible?
We can't have a 13 psi pressure without a barrier. That's my whole point, Daniel. You cannot have a pressure gradient without a barrier. You have to have a barrier, because like the helium balloon shows, when the balloon bursts, it immediately fills the volume. So if the volume is the vacuum of space, by virtue of the pressure gradient that we do actually have, it means that we cannot be existing next to a vacuum of space, because it would immediately fill that container, Daniel. So the fact that we have a density gradient or a pressure gradient confirms that we must have containment of some kind, because you can't have a density gradient without containment.
Okie dokie, so I've just asked for more questions, so we'll see what happens. Right, so from Jimbo, mass per unit volume and density. The difference, do you know it?
Mass per unit volume and density. Well, density is mass over volume. And what was the first bit?
Well, that was it. It was the full question is, Riley, mass per unit volume and density. The difference, do you know it?
Mass per unit volume. Yeah, that's mass. And then density is mass over volume. So the difference is the volume.
Okay. So how do you calculate the acceleration from falling if you have the density of the gas and solid object?
Oh, that's easy. Look up the definition. Well, okay, so the density is the density of the object divided by the density of the fluid based on water. So you get a ratio, and then from the ratio that you get from that, then you can calculate, or you can then apply the ratio and work out. Well, I don't know how it works because I'm not a mathematician, but if you just look up specific gravity and then look up actual specific gravity without gravitational forces being applied, and you'll see that it's literally the density divided by the medium, and then that ratio, it tells you how far away from its equilibrium point it is, and that there's a correlation between its acceleration. Now, that's the mathematical answer. Whether it's true or not, maybe it's true, maybe it's not, I don't know. But the answer lies in the definition of specific gravity for the ratio that you get from it without gravity being applied.
Okay, so from Marco Crean, do you think the barrier is physical?
No idea. It could be metaphysical. It could be to do with temperature, like Spurs argues. It could be to do with... Well, what we do know is if you look at the phase diagram for the top elements in the atmosphere, so you got like helium, hydrogen, oxygen, nitrogen. Look at the phase diagram for each of them. If deep space, the absolute value for space is, what is it, minus 235, is it? If you look at the phase diagram and you look at the pressure and the temperature relative to the hydrogen, the oxygen, the nitrogen, all the gases, a lot of them exist in a liquid state or a solid state at that temperature and pressure. So if that's true, then the only argument really is what volume is there of these gases that are now in a liquid or a solid state. So the answer to that question is it a solid barrier? If you look at the phase diagram, it indicates that it would be, subject to the volume of these elements that would be above or below, because it appears that the sun burns these elements as its fuel, and that stops the barrier from internally imploding. Imagine that you've got like... Do you remember the giant gobstoppers that had a little seed in the middle? If you sucked a giant gobstopper, eventually you'd get to a little black seed in the middle. The little black seed in the middle would be the sun, and all the layers of the giant gobstopper would be the layers of the atmosphere. Well, eventually the sun can't burn all those elements, and could it be liquid? Could it be solid? Well, according to the phase diagram, yes. Based on evidence, I don't know. That's the evidence that we're asking for. The answer to the question is, I do not know.
Okay, I'm trying to find the previous question from Rock Farmer. Just 1 second, because he's asked another follow-up question. Just bear with me. So he's talking about two identical tubes, one at 5 psi and one at 20 psi. Will objects fall at a different acceleration? Why not? You've answered that. So the follow-up question is, so if you understand Riley correctly, is he saying an iron ball will fall faster than a feather since it is more dense, all other things equal?
Well, we saw with my egg experiment that when I increased the density of the medium, it created an acceleration. Well, that indicates that if you change the medium and you can change the acceleration, if you change the object and change the density of the object relative to that medium, then you're going to be able to vary the rate of acceleration based on how far away from its equilibrium point it is. So if you get a lead, so look at the anvil, for example. When the anvil is sat on top of the liquid mercury, the anvil floats, even though it's very dense. But if you were able to manipulate the density of the liquid mercury and make it less dense, at some point that anvil would start to accelerate down, in quotation marks, because you're changing the density of the liquid mercury. But if you drastically change the density of the liquid mercury and put it as water, that anvil is going to fall straight through it really quick. So the answer to the question is yes, it all depends on the medium and how far away from equilibrium the target is. If it's far away, the acceleration rate can be will be fast. If it's close to it, the acceleration, like I demonstrated in the egg experiment, it'll be small. So it's all scalable based on how far away from its equilibrium point it is, and you can demonstrate how far away from equilibrium it is with a set of scales. You stand on it and your mass weighs 15, 18 stone. Well, that shows how far away from your equilibrium point it is. That demonstrates that you'll sink before your mate if you're more dense, because you're further away from your equilibrium point. If your mate's lighter than you, he's closer to his equilibrium point and he's going to float easier than you are. You may both still drown. You may be far enough away that you'll displace the water, but your mate that's lighter is going to float easier than you are because he's closer to his equilibrium point.
So a super chat question from Anthony Dickinson, who says, is the firmament keeping us in or evil out?
Is the firmament keeping us in or evil out? To be honest with you, my own personal view, the stars are the firmament. I think that the fact that the stars don't have any stellar parallax. I mean, if you look at Betelgeuse, and if you look at Sirius, I think it is. Yes, I think it's Sirius and Betelgeuse. They're right next to each other in the night sky. Sirius is one of the closest stars, whereas Betelgeuse is something like 464 light years away. It's one of the really far away ones. There has to be stellar parallax. There is no measurable parallax between Betelgeuse and Sirius. There has to be. Look at it as a ratio. Apply the ratio. Betelgeuse will always stay still. Sirius will always parallax Betelgeuse. But in the real world, it doesn't do it. I remind myself of Werner von Braun's tombstone, and I'm going to butcher what it says, but it says something like, for the firmament showeth God's handiwork, or words to that effect. I don't know what he means when he says the firmament, but I'm pretty sure he's referencing the stars. And I think the stars are the firmament. I think we're looking at the firmament every time we see the stars, because they're definitely not light years away, because there's no stellar parallax. You'd never see the same star patterns twice if there was stars that far away, because they would continuously be parallaxing each other. You wouldn't have star patterns. Balder's got some nonsense explanation, but do you know what? I'd rather argue that the firmament is flexing caused by convection currents from the sun than argue that the stellar parallax that clearly is not there. It's nonsense. I hope that answers his question.
Okay, so from Polster X, if objects fall due to relative density, why would an iron ball and a less dense wood ball fall at the same rate in a vacuum when the density differential would be different?
Because the medium is zero. Anything falling in the vacuum, the medium is zero. The reason why they all fall at the same rate, there is a maximum velocity, a terminal velocity that seems to be set by the creator. You don't question why it is that hot goes to cold. You just accept that it does. You don't question why pressure goes to non-pressure. You just accept that it does. But you do question why objects displace the vacuum of zero. Well, the answer is because the vacuum is zero relative to the mass that it's in. That rate of velocity is set. Why? Who knows? I would argue that that's proof of creation. Obviously, you guys will say, "Oh, don't be ridiculous, science, bro." But the fact that there is a terminal velocity in itself proves that there has to be something that's programmed that speed. For me personally.
Okay, so speaking of science, we have a question again from Chris Krul. If science could show that gas pressure is just energetic molecules ramming into each other and doesn't require a container, would you change your assumptions?
Well, we can demonstrate that the little cherry tomato inside its own container, if you ignored the fact that there was a container there, we can demonstrate that there is fluid pressure within the layers based on just the layers being there, but there still has to be a bigger container containing it all. So if you can demonstrate in a vacuum that there would be gas pressure, 2 or 3 gas pressures layered in some way anyway, yeah, I'd accept that. But guess what? No science can demonstrate gas pressure within a vacuum. It's completely impossible. That's why we're asking the question.
Okay, so from Peter G, is the burning in the sun a nuclear reaction or regular combustion? If it is combustion, why do we detect a lot of neutrinos from the sun?
What burning in the sun?
So you're saying that's
You're assuming that the sun's a physical object of fusion or whatever the current science is for what the sun is. They can't even agree on whether the sun's a liquid, a fluid, a mass, or a gas. So are you going to argue that you know what the sun is? I'm going to say bullshit. They're still arguing what the sun is. I tend to lean more towards Arwin when he says the sun is metaphysical. I look at the sun and I think that reminds me of when I was young and I used to get a magnifying glass and I used to concentrate the focal point of the light from the sun onto a small pinhead and set fire to ants. That's what I would imagine the sun to be, because it looks just like that. It looks like a white spot. Instead of being on the floor, it's in the sky. And I imagine that that's a focal point of light, just the way that we used to burn ants with when we were kids with a magnifying glass. But if you're going to tell me that the sun is some kind of physical attribute, I'm going to say, how the hell do you know that? And the answer, of course, is he just believes it because he's read it. But the fact is, they're arguing over whether the sun is a fluid, whether it's a gas, or whether it's a solid. The mere fact that there's a discussion over it within science means that you don't know what you're talking about and you just believe what you've read. The answer is they can't prove what the sun is. If they could, and it was a physical object, there would be proof of it. But the reality is there is no proof that it's a physical object.
Well, just to clarify something there, I never burnt any ants with a magnifying glass as a kid. You might have done, Tony, but not me. Anyway, question from Charlie. Does Anthony really believe that the atmosphere has layers of different gases? If so, why are we not in CO2 as it is more dense than oxygen or nitrogen?
Well, CO2 is not a gas, is it? It's a mixture of gases. It's carbon and oxide mixed together. So it's not really a gas. It's like a compound of gases. Do I really believe that the atmosphere is layered? Well, if the atmosphere wasn't layered, you would not be able to get sulfur hexafluoride in a fish tank without it immediately filling the available volume. But the fact is, we can get sulfur hexafluoride, a heavy gas, existing in the atmosphere that we're told is gas. So if you can put a fish tank and fill it with hexafluoride and then put a little tinfoil boat on top of it and it acts like it's acting on water, even though you can't see it, that tells me that the atmosphere can layer. Now, we have a dynamic system. The sun mixes it up like a giant paddle on a boat, on a kayak. So if the sun's acting like a giant paddle and it's mixing everything up, then you are going to get a mixing of the atmosphere. But it makes you ask the question, when mountaineers climb Everest, why is there a point called is it called Deathman's Valley, or the point of no return, where if you do not get to the summit of Everest and then back again within 2 days, you will die of what's it called? Lack of oxygen. I can't remember what the asphyxiation is. It asphyxiation? I can't remember what the word is, but you will die from not having oxygen going to the brain, because it's as if you're going above the point where the oxygen is in the atmosphere. I know they say that the oxygen is diluted that much that you can't benefit from it, but I'm thinking that it's more because you've come out of the layer of the atmosphere that has oxygen in it, and you're now going into the layer of the atmosphere that does not have oxygen in it. And the fact that sulfur hexafluoride in a fish tank with a little tinfoil boat floating on it supports the idea that you can have separation of gases in the atmosphere, but the sun mixes it all up. So to answer the question, yes, I do think that we can have layered atmosphere, layered gases in the atmosphere. Sulfur hexafluoride is the proof of it, otherwise it wouldn't do that. But the sun mixes it all up, so it makes it a little bit difficult, because you'd have to remove the sun to prove it one way or the other, and obviously we can't really do that.
Okay, so question from right at the hand. So he's talking about himself here. He said, down and up are objective directions, not relative ones.
I didn't. I said they're relative.
No, he said, he's talking about himself, so right at the hand. I said, so he's talking about right at the hand. So I said down and up are objective directions, not relative ones. That's his assertion. Does he think, so he's talking about you now, do you think up and down are objective and up is always up to the sky, or are they relative to each person?
There's two answers to that. If you just Google relative directions, it tells you that up, down, left, right, forwards and backwards are all relative directions. I accept that. But the other answer to it is, do I think that they are relative directions? Yeah, absolutely. Without the human there, you wouldn't have a direction. The direction comes from the fact that your feet are on the ground, and that's how we perceive up and down. If you hang upside down from a tree, then your up and down then becomes questionable. Your left and right is back to front. So it's always relative to the human. Up, down, left, right, forwards and backwards are relative to the human. And obviously that's the reason why Bob from Globebusters is wrong when he believes that there's a universal up and down. That's why Nora is wrong when she believes that there's a universal up and down. And that's why Mark Doxey is wrong when he believes that up and down is objective. It isn't. Without the human, there wouldn't be a reference point. The only absolute direction seems to be the magnetic north. Whether or not declination exists or not is a moot point. But we can all use a compass, and we think that they all point the same direction, declination or otherwise. We'd probably end up in the same point if we had a compass and we all carried on walking or swimming or whatever. But absolutely speaking, up, down, left, right, forwards or backwards, by definition and practical application, are relative to the human, and they are not objective.
So, guys, in the background, you're going to see, where is it? Here. This is the most awesome sunset I think I've ever seen. So somebody got in touch with me today and showed me this that they filmed over the North Sea. Absolutely stunning. So if you want, I'll put the link into the description. You can go and download the video for yourselves later. So a few comments about saying I look a bit Ken-burned. Well, I am under the most amazing sunset. What do you expect? Right. Question from Gleam. Medium of God or medium of unshieldable electrostatic field of Earth?
Right, just 3 more questions and I need to go to bed. I didn't understand the question. Could you repeat that?
Medium of God or medium of unshieldable electrostatic field of Earth? Question mark. Then he goes on to say 5 words or 6 words it makes no sense, which is on maximum rate of induction point.
To be honest, I don't even understand the question.
Yeah, there's been a few questions that have been a bit malformed. Right, let's...
2 more, then I'm going to bed.
You said 3. You didn't get to answer that one.
Well, I did. I said I didn't understand it. Come on.
Okay. Do you need a human for a tree growing up to the sky?
No.
Okay, so 2 more questions.
Hang on. Do you need a human for a tree growing? No. Up to the sky. The word up is an issue. Do you need a human for a tree to grow? No. Up to the sky. Yes, you do need a human for up to the sky because up's relative to the human. So initially my view was no, you don't need a human for a tree to grow. But then I thought about the addition of the word up to the sky and then realised that you do need a human for the up to the sky bit, because without the human it's not up, it's just the tree's growing. Up and down, left and right, forwards and backwards are relative directions, relative to the human.
How about this one then? If you hang by your knees from a tree branch with your head towards the ground and you straighten your legs, do you fall up?
That's because up, down, left and right are relative to the human. In that case, he would fall up, wouldn't he?
Right, one more question, guys. Let's see if we can get more one in. I'm just going to wait to see the next question, and if it's typed with question, I'll say it, and if it's malformed, so be it.
And then I'm going to bed.
Yeah, me too as well. Me too. We're from the UK. It's 11:15.
Yeah, and I'm up early in the morning.
Okay, here we go, from Chris Cruel. If an object falls in a forest, does it fall in a downward direction if a human is not around?
No. Up, down, left and right, forwards and backwards are relative directions by definition.
Okay, well, awesome. Thank you, Tony. Thank you for the presentation. And you answered every
question. No worries.
Question. You answered every question, and yeah, pretty cool. You kept your head as well.
Yeah.
Well, very good.
Well, there was one I didn't understand to do with is God the medium or whatever. Shout out to whoever asked that, because that was a really interesting question. I'll go back and listen to that one and try and understand what you're asking.
Well, just so that you guys know, we do have a fight night on Wednesday. So on Wednesday, on this round table format, we're going to have the first ever fight night, and that's going to be between Right the Hand and Brenda von Assen, and it's going to be over, can you guess, Tony?
Quantum physics? Yeah, quantum mechanics.
Yeah. So that's going to be the very first round table fight night. So it's going to be 5 questions each. Obviously, I'll go through with the guys and lady off air prior to the show so that they know the format. I'm expecting the questions from both over the next few hours, so I'll have them. I can swap them over to these people. They'll each have each other's questions prior to the debate. So tune in for this Wednesday's first ever fight night on the round table. So it's what I've wanted to get down to, basically a presentation from both sides, one on one.
Do you know what I'd like?
Go on.
Let me just say one thing. I'm not sure how strong the evidence is for quantum mechanics, and I'd like to see somebody challenge John on it, because I'd like to see the discussion. My only problem is with Right the Hand and John together. They both seem to be of the same nature in that they both want to kill each other. But I'd like to see the discussion. So if Right the Hand could control himself in a way that allows John to be John, it would be interesting to see what the criticisms for against quantum mechanics actually are, because I don't know how strong the quantum mechanics arguments are, and I'd like to see it challenged and a respectful disagreement come to a closure, because I'll be honest, I'm not intelligent enough to work out how quantum mechanics does or does not work, but I'd like to see the discussion. So Right the Hand, if you could control yourself, that would be cool to watch.
You're already bypassing Brenda now. Brenda's done the presentation when Right the Hand was the one calling John out. So Brenda stood up. She took the challenge up wouldn't say necessarily on behalf of John, but she definitely rode to the rescue. And who knows? I mean, it could be that Brenda's the one to win out on this particular argument, in which case John wouldn't even be needed. Who knows? We'll see where it goes on Wednesday.
Yeah, but she cites Kant, and Kant was debunked years ago, and I'm like, why would you cite Kant as an authority when he's been superseded by deductive reasoning, deductive experimentation rather than inductive experimentation? Anyway, listen, I'm going to drop because I need to go to bed. So thank you all, guys. I'll catch you tomorrow.
Okay, see you later, Tony. Right, well, thanks very much, guys. That's been episode 14. Gravity Cannot Hold the Atmosphere to the Earth with Sleeping Warrior. He seemed to answer every question that you guys put to him. So I hope you all enjoyed it. We've got 29 thumbs up, 19 thumbs down, and we've had a few super chats today, which has been pretty awesome, actually. It's nice to see a super chat now and then. It does help keep the show rolling. So, tune in on Wednesday when we've got the first fight night, Brenda Von Assen and Right the Hand, and hopefully that will be close to a 2 hour, roughly, I would expect, a 2 hour debate. So, obviously I'll be the moderator, and looking forward to it, looking forward to the first ever one. So, I guess that's all I need to say. Thanks all for stopping by, guys, and I'll see you all in the next one.